All right, some pulley problems. Let's do this. Static friction 0.61, kinetic friction 0.47, coefficients of mass 1, 10K, mass 2, 2K. So let's see what's going to happen. So it'd be kind of like having two pulleys like that, having two things over a pulley, and you got 2 kilograms here. And what's the effective thing that's pulling on the string? The tension. That'd be the component of gravity pulling down the plane. So if we figure that out, is this thing going to go down, or is it going to go down the incline? You know, is this going to go up or down? Will this go up or down? So we can think of it as if that's 2, and the force down here would be, remember, the force parallel to the inclined plane, mg sine theta, force perpendicular to the inclined plane for gravity, mg cosine theta. So the parallel part would be 10 times 9.8, 98, sine of 40, 9.8 sine 40, under 6.3. So it's like having something like this with 2 here and 6 here. It's like equivalent. So it's going to be going down this way, okay? So if we work this stuff out, see what the acceleration is going to be and some stuff like that. Again, M1, M2, and forces on this one, free body diagram stuff. Gravity's pulling it down. And so force of gravity, tension this way. And here we have tension this way, parallel force of gravity that way. And since we know it's going to be moving down, the force of friction is that way, because it's opposite the direction of motion. T, F parallel, F sub F, force of friction, force of gravity, tension. So do Newton's second law. So we got remember, right, I'm counting as positive. Left, I'm counting as negative. So down to the right, because this is to the right of the thing. And here, if we go to the left, it'd be down to the left this way down the plane. So here I got tension plus force of friction minus the parallel force is M1A. Over here, force of gravity minus tension is M2A. Then we can figure out the numbers and put them in. That could make some things easier for some folks. F parallel, F perpendicular. In this case, that'd be the normal force. Because the normal force is supporting part of the weight going perpendicular to the plane. And so, force of friction, component of friction, times the normal force. There's enough of a difference, so it's going to start moving. Don't really got to worry about static. It's enough of a difference. And kinetic will come into play. I'll just do like kinetic first, make it easier. So here, if we get the parallel component of force for M1, of course, because this goes for this one, this goes for this one. So we get M1G sine of 40. So I guess I already calculated that out, yeah, earlier, 6 something. So 10 times 9.8 sine of 40. So 10, and that was in terms of mass, not that. Okay, so in terms of force, 63. So T plus something minus 63 will be 10A. Let me get the force of friction. So the normal times the kinetic. So we got 10 times 9.8 times cosine 40. That's 75.07. And then 0.47. So this part was 75.07. So gravity's pulling it down at 75 newtons. So the board supports it at 75 newtons. So that times 0.47. Whoops. 100 times 0.47. 35.28. So this is 35.28. Round it to 35. Over here, this is 9.8 times 2, 19.6. And then 2A. And so then solve for T. First, 35 minus 63 is going to be 28. So T minus 28, 10A. And then T, I guess I'll just go ahead and solve for T. 10A plus 28. Move the T over, subtract that. 19.6 minus 2A is T. So they're equal to each other. So 10A plus 28, 19.6 minus 2A, add 2A, subtract 28, that'd be 8.4, 8.4 over 12. Um, 0.7. Okay, 7/10 meter per second squared, unless I did some calculator or mental math wrong stuff. So make sure T, right, left, right, right, left, that, and then put the numbers in. 2 times 9.8, T minus 2A. Then we got that and that. And 28. I think it's okay. And then 0.7 meters per second squared would be our acceleration. Then we can do other stuff with it, like velocity, distance, time stuff, equations of motion. But they're putting in the numbers and doing that, and it can be easier for some people instead of the formulas. Okay, so let's say if we do change some numbers here, switch them out, make it 2 and 10. Then it's going to be going down this way. And then this should have been negative. Sorry, move that. Negative, negative. Okay, that makes more sense. So, because I was thinking if I'll make this 10, it'll be going down. It should be the opposite of what happened before. So this should have been going. And since going this way is negative, I should end up with negative. I forgot about that. So I corrected it. Error analysis. So negative 0.7 meters per second squared. All right. Then we switch it out like that. What's going to happen? Then we know that this parallel force, it'd be the weight decreased by sine of 40. So it'd be a fraction of the weight. And this is going to weigh less than this already. So we're going to be going down this way this time. And so we got in this case, we still have force of friction, or the weight, tension, then over here, tension, parallel component of the weight. But since we're going this way, friction acts opposite direction of motion, force of friction will be going this way. So we got tensions to the right, these are to the left, so negative. And that, then we can plug our numbers, crank it out. So force of friction, I get parallel, force of friction. So get the normal force, multiply by 0.47. In this case, M1, 2 times 9.8 times cosine of 40. 2 times 9.8 cosine 40. 15. So this will be 0.47 times 15. 9.8 that. And then times 0.47. 706. In the parallel, the weight becomes a factor of sine 40. So 2 times 9.8 sine 40. 12.6. And then 2a. The timer's going off. Let me go turn that off. 1 second. Okay. Then over here, the weight, 10 times 9.8, 98. And then 10a. So now they're equal to each other. We'll solve, like this minus this. T minus 19.66 is 2a. So T 2a plus 19.66. With the T over, subtract that. T 98 minus 10a. So they're equal to each other. 2a plus 19.66 is 98 minus 10a. Add 10a, subtract that. We get 78.34. And then divide by 10. 7.83 meters per second squared. And you can see this time it's positive, so we know it's going down. So it's in free fall, modified, held back a little bit by this. So there's two inclined plane with friction.